Hi, my name is Jabal Konbong, and in this video, my group is going to talk about the Bayesian theory. The Bayesian theory helps in giving the probability of an event that may happen. It provides us a way to mathematize our belief or knowledge in our daily life. Prior probability is the knowledge that we know containing the probability of specific events or hypotheses that may occur. For example, the subject knew that the probability of raining today is 70%, while the probability of not raining is 30%. The state of nature is a random variable if it is exhaustive and exclusive. For example, the probability of first event added with the probability of second event must be 1. The decision rule decides with prior information, which is it will decide event 1 if the probability of event 1 is more than the probability of event 2, and vice versa. A class probability is the probability of an event that will occur as long as the previous event has actually occurred. For example, the probability of x given event 1 has occurred, or probability of x given that the second event has occurred. The decision rule, according to the class probability, decides with the prior information. It would choose event 1 if the probability of x given that event 1 has occurred is more than the probability of x given that event 2 has occurred, and vice versa.
Posterior probabilities. The probability of a category given that feature values have been measured. Bayesian formula to combine prior, for example, probability J and a class conditional probability, for example, probability X given W1. Probability of Wj(x) is equal to probability of Wj given x multiplied by probability of x, which equals to probability of x given Wj multiplied by probability of Wj. Probability of Wj given x is equal to probability of x given Wj multiplied by probability of Wj divided by probability of x, which is directly proportional to probability of x given Wj multiplied by probability of Wj. A typical decision rule is to choose the class with the highest probability of W given x. How to make decision with a given posterior probability. X is an observation for which if probability of W1 given x is greater than probability of W2 given x, the true state of nature is equal to W1. If probability of W1 given x is less than probability of W2 given x, true state of nature is equal to W2. We can calculate the probability of error whenever we make a decision.
The probability of error for two class situation we have the probability error that's given as equal to pw1 x if we decide w2 and otherwise pw2 x if we decide w1. To minimize the probability of error by following the posterior, we will decide w1 if pw1 greater than pw2. Otherwise, we decide w2 if pw2 greater than pw1. This is the minimize the average probability of error too. So this is the formula. It is not that because the integral will be minimized when we can ensure each probability error that's given x is as smaller as possible. Therefore, the probability of error becomes the probability that we have met an error will be equal to the smaller of the two posterior. The probability if say that the posterior of W1 is 0.9 and the posterior of W2 is 0.1, so we will pick 0.9 because because it was larger, but we will also note that we have 10% chance that we have made an error. Equivalently decide W1 if class 1 greater than class 2. Otherwise, we will decide W2. If we have condition 1 equal to condition 2, then the decision will rely exclusively on the pilots.
Hello, my name is Ifa and I'll be talking about the continuous features of our topic. Continuous features help to improve a model by allowing the use of more than one feature, for example like adding the shape of the cards as another feature, allowing more than two states of nature also. For example, having a deck also containing clubs and hearts. It also allows actions other than merely deciding the state of nature. Continuous features also introduce us to loss function. So before we move on, feature space is the use of more than one feature, meaning that we would replace the scalar y with the feature vector y, where y is in a d-dimensional Euclidean space Rd. Feature space allows more than two states of nature, provides a useful generalization with small notational expense. Allowing more actions also opens up the possibility of rejection or refusing to make a decision in two closed cases. This can be very useful if being indecisive is not too costly. By putting this together, let this be the finite state of C states of nature or categories, and let this be the finite set of A possible actions. So for the loss function is it states exactly how costly each chosen action is and is used to convert a probability determination into a decision. The loss incurred for taking action A1 when the state of nature is Wj. Here is how to calculate the loss function. By having the loss function, the cost functions, it enables us to look at situations where certain errors are more costly than others, although we will only often be looking at cases where all errors are equally costly. For the conditional risk, it is the expected loss of taking action A1, and this is how to calculate the conditional risk. For the overall risk, it is the expected loss associated with a given decision rule, and this is how to calculate overall risk. So how do we choose the lowest or minimum value of the conditional risk? We use Bayes' decision rule, where if this is more than this, then we choose this one, or if this is more than this, then we choose this one. So basically we just choose the lowest minimum value of this. That's all for me. Thank you.
For two category classification example, consider there are two actions and two classes. If action 1 is true, then we decide class 1. If action 2 is true, then we decide class 2. So this is the conditional risk formula for two category classification. For action 1 given x and action 2 given x. Next, the fundamental decision rule, we decide class 1 if action 1 given x less than action 2 given x. In terms of posterior probability, we decide class 1 if lambda 21 minus lambda 11 times probability of class 1 given x more than lambda 12 minus lambda 22 times probability of class 2 given x. Or in terms of prior probability, we can basically write it like this, or we can assume it as this formula, where the left side is the likelihood ratio and the right side is the threshold. Then the Bayes decision rule decides W1 if the likelihood ratio exceeds the threshold value.